And then there's sort of two things we're going to look at. The first one is the solver analysis tab, which is new. So for those of you who've done research with me before, you've never seen this. This is a little bit different. And so we've got this as peak 1, peak 2, and peak 3 analysis right now at every temperature. And it has those parameters A, M, W, L, W, G, and X for each of those 3 peaks. And what I've gone through is these are actually automatically pulling those numbers. So as the fit changes, these are automatically updating. So don't change any of these cells. They're already set. You don't need to copy and paste anything in here. And what this is going to, and these are actually also plotting down below. So what we expect is that peak 1, which is sort of the blue here, we expect that, well, okay, so let me be really honest. Peak 1 at 1680, we have no idea what that mystery peak is. It only shows up in certain samples. It moves around a little bit. In the same sample, it shouldn't move around much. So we don't know what it is. So we don't really know what to expect from it. So its amplitude in this particular sample looks like it decreases maybe a little bit, but not very much. A2, which is our 2 hydrogen bond peak, which is at 1704, 1705 inverse centimeters. The amplitude or the absorbance of that peak is actually going down, which means we're getting less and less of that species as we increase the temperature. We're breaking hydrogen bonds. So that makes sense. The gray, which is A3, that's our 3rd peak at 1725-ish inverse centimeters. That represents 1 hydrogen bond to the carbonyl. And so we should expect that as 2 hydrogen bonds are breaking, we're leaving behind 1 hydrogen bond. So that peak should go up in absorbance, and it does as temperatures increased. The shape factors, however, which is our M values, should be fairly constant. So we can see we have some problems with this data set and that they're not very constant, particularly around 40 and 45 degrees. We've got something kind of strange going on with the 3rd peak. So these should be almost constant for each peak. So not that each peak should be the same, but say peak 3 across all temperatures should be fairly constant. So we want to make sure that these are not moving around, and these are moving around a little bit. So we probably need to go up, fix those fits a tiny bit. And then we have our Lorentzian and Gaussian widths. These should also be fairly constant. There shouldn't be any craziness going on for any of our peaks. And our position should be almost perfectly constant as a function of temperature. So this really shouldn't change at all. So we do notice that we have some small changes in the Lorentzian width and in the Gaussian width, mostly in the Lorentzian width, and we have some small changes in our shape factor. And so what this also is doing up here is there are some average values, and this may or may not be in the template. I don't remember if this made it in the template, but you can average, right, the area or the absorbance, that amplitude. We expect that to change, but we don't expect these other things to change. We're taking an average here to sort of see what the averages are. We can then take these averages and put them back in as our initial guess and rerun solver. And it should update once you rerun solver with those values. And we should see that some of that scatter is going to clear up. So we're going to get better, hopefully, when we do that. So it's just sort of a double check to make sure that your fit is correct.